Okay, I'm getting my power poles set up. I've stripped the wires off of the ends off of some wires that I'm going to use for it. And then I'm crimping the power pole ends on. This is what it looks like when it gets done being crimped on. I'm using a power pole crimper here that I bought a number of years ago. Makes a really good connection. Okay, after crimping the ends on the wire to assemble the power poles, you look at the power pole and the actual power pole itself, and there will be a metal tab. You put that to the bottom, and then you shove it in so that the looped, or the side with the bump is the bump side is up above the tab in the power pole. Now I'm using 14 gauge stranded wire here, but it's kind of a stiffer wire, so I'm going to have to push really hard to do this. I'll go ahead and shove it in here in a second and show you the completed power pole once I get it in. Okay, here it is completed. You push it and you eventually hear a snap, and then it's done. Okay, now I've put two sets of power poles together, and then another set of two sets of power poles together, and then I'll stack them on top of each other. Okay, with all the blocks together, I went ahead and labeled each one of the positive wires for which port it's for. And then on the end of the positive wires, I've put these connectors on, which will slide into this fuse block, the blade fuse block. And so we'll go ahead and slide those in there, and then put both of them into the panel in a later step. Starting the wiring of the power management unit project, there's actually two sets of wiring that we need to do. We need to wire the power supply into the relays to the outputs. And then the other thing that we'll need to do is do our wiring from the LCD panel to the Arduino, and then also the controls to the Arduino to the relay board also. We're going to start with wiring of the power supply first. I've had an assortment of these crimp-on terminal connectors that I need to use up. I'm not particularly fond of how well they crimp on, so I'm going to go ahead and cut the insulators off of them, crimp them on, and then solder them, and then go ahead and cover them up with shrink wrap or shrink tape or whatever. Then I'm using this 12 gauge zip wire to make the initial connections for the power supply. We're going to fuse the hot side of the wire, so this wire, or this is the terminal that we put on to go into our fuse block. Finished up the initial power connection cable, and it turned out, I'm pretty satisfied with the way it turned out. So we'll connect that up and move on to the next. There's a few more of the electrical power supply wires that I've done, and I've put the heat shrink tubing on and crimped everything, and they don't look too bad. I have the wiring run from the power receptacle over to the fuse block. I've got a 20 amp fuse in there, and I'm coming over to the back of the switch and powering that up, and then going from that into the power supply. I have the hot side fused on that, so let's go ahead and turn it on and see if we get a light. Oh, we do have a light on the switch. You can barely hear it, but the fan is spinning on the power supply. So the next thing I'll do is I'll go ahead and hook up the volt ohm meter to the power supply and adjust it so that we have 13.8 volts. Okay, I have the volt ohm meter hooked up. We'll go ahead and turn on the power supply and see where we're at. 12.08 volts. There's a little trimmer down there that you can turn to adjust the voltage, so I'll go ahead and put my tool in there and we'll see what we can do here. Yeah, it's a little sensitive. I'm going to leave it right there at 13.85 volts. So now we'll go ahead and start wiring in the relays over here into the power, and then the power poles. Then after we get done with that, we'll go ahead and start wiring up the controls from the LCD panel to the Arduino. Here I have the power poles mounted in the back, and you can see I've routed the positive side over to the fuse blocks, and then I have the negative side coming over here, which of course will get connected to the power supply. I'm going to try something I've never tried before. I found these crimp, lever crimp connectors. I'll tie all those together in there and just run one wire into the power supply. I'll probably end up doing that for the positive side too, because for the current sensor that I have, I'm going to measure the current coming out of the power supply before it goes into the relay box. Backside of the power poles don't look too bad here. You can see that turned out okay. The fuse block turned out okay, so far so good. So I'll go ahead and continue tying this all together, and then hopefully here pretty soon we can get started on the wiring of the controls for the Arduino. Well, we have those connections made from the negative over to the power supply here. I ran that underneath the power supply. I have to say I'm really very happy with these. These snapped right in, real solid connection. Not a lot of work involved with it. I probably use these again in the future. So now I just need to run our wires from the fuse block down to the relay board, and then from the relay board over to the power supply. We'll use that same connector for that, and then we should be done with wiring up the power supply part of it, other than the 5-volt power supply. I'll have to tidy these wires up a little bit here. At this stage I've got the power supply all pretty much wired up, except I need to add a ground wire yet. I went ahead and wired up the 5-volt power supply to the main power supply, and I like these connectors so much I decided to use them for the 5-volt power supply also. So the next thing we'll do is we'll start hooking control wires up to the Arduino, the LCD, and the relay board. Okay, I've got the wiring pretty much done to the point where I had it on the breadboard. I still have to come up with the circuit and the coding for the momentary switches and the LEDs, but that's not very hard to do. And then I also have to come up with the circuitry for the current sense, which I will clamp over this wire here to determine the amount of current. And then obviously once I get everything done, we'll tie this together so it doesn't look so bad. But it's all hooked up now. I turn the power on. My LCD comes up with the beginning display. And then it starts reading that. I still have to adjust the voltage divider a little bit so that reads correctly. You can see the lights on the Hoare relay board are lit. Those have a light. It's hard to see down there on the 5-volt power supply. Got a heat sink on that 5-volt power supply, and it's a good thing I do, because that LM805 gets really hot. We're probably, once we've got the relays all energized and we're powering the Arduino board and the LCD, we're drawing just shy of 1 amp on that, I believe, and so that really draws a lot of power through there, and that thing gets really hot. I was worried about it at first, but I let it run for a couple hours and it seems to be okay. I did find that I had to switch the fuse for that particular circuit from a 1 amp to a 2 amp, because being right at 1 amp it was blowing that fuse, but I put the 2 amp one in there and it seems to be okay. So what we're doing next is we're trying to go ahead and finish the circuitry on the other 2 circuits, as far as the momentary switches and the LEDs, and then the current sense, and then we'll be about ready to wrap this project up. So I'm going to sign out now. This is KB0ASQ signing off.